Cool. All right. Thanks for coming, everybody. We got a good turnout tonight. So tonight, our topic is WebAssembly and Uno. Andreas is going to present this topic for us. Been looking forward to this. I know everybody's really excited and interested in WebAssembly, so it's going to be great. I've been watching Uno too, so this is going to be great. Just a little bit of housekeeping before we dive into it. So location, so normally we're at 485 Queen West next door. Today we got the bigger space, which is great because we got a bigger crowd. So we're usually also the third Tuesday of every month, an exception this month. But if you want to join us, look on Meetup. I'm sure that's how most of you found us. We meet almost every month. The exception is the summer and usually December. So I hope to see most of you again in November. So our upcoming, trying to find a speaker to do reactive Xamarin apps. So I'm working on that. We'll have somebody booked by the time November 20th rolls around. And we'll see about that. So we're, again, back next door. So if you would like to speak or present something that you've done, you don't have to present a full hour-long topic or anything like that. If you've done something cool with Xamarin and you want to show it off, please let me know, and we'll schedule you to present at one of the upcoming talks. Always interested to see what the community's doing. If you've got something that you want to share, we'd love to see it. So really, if you want to cover any of these things, we know mobile's a big space with lots going on. So anything around frameworks such as Uno, any tooling. If you're doing something unique or very targeted to mobile design or delivery on mobile platforms, or if you just want to talk about, hey, this is what I've done or this is what I've come up against, it's always good to hear that. People like to hear that. It's always interesting to talk through the way people have tackled the challenges in the space. If you want to connect with us, we've got all kinds of social media. I tweet very often. Daniel tweets from our Twitter account. Of course, we're on Meetup. I'll draw some special attention to GitHub. We've got lots up there, including the app that we've built for the user group, which we're hoping to launch very soon and just haven't gotten around to it. But the code's all up there, so if you want to take a look at it, if you want to grab it and use it as a starting point for your own project, it's all on there. Our YouTube, of course, we're streaming there, so if you want to go back and pick up any of this, we're doing a screen capture too, so if you go like, oh, where's the Connect slide? I don't know what any of these links are. You can go to our YouTube page, and you can easily find the live stream and the recording from the last session. We also have a WhatsApp group where we kind of do some just random chat on what's going on in mobile. I'd like to thank our sponsor, BSI Labs. James, you want to come up and say a word or two?
I don't want to take too much of your time here because you didn't come to listen to marketing, so I'll be quick. But thanks a lot for coming out tonight, guys. I'm James Schwartz from BSI Labs. I'm a partner there. We do full-service mobile enterprise app development. We also do user experience design and QA testing. We have project managers, we have business analysts. We do the full spectrum projects. So yeah, if you're interested in checking us out, check out our website. And I want to thank Dylan as well for coordinating these events. He's been doing this tirelessly for over a year now. So thanks, Dylan, for putting this on. And yeah, thanks, Andreas, for coming out today to show us what you got. So without further ado, I'll get back to you guys.
Cool. Thank you. Just a couple more quick things. So one last thing, really. So just another, I always like to plug the regular .NET group, the non-mobile focused group. They've got all kinds of interesting topics, lots of Azure stuff. So if you're doing work with Azure, they're covering a lot of Azure topics, and they meet the Tuesday after us generally. So usually they're the last Tuesday of the month. And they're over at the Microsoft office. So always good to join up with that group as well. They've always got a lot of stuff going on. And yeah, without further ado, guys, you want to take the stage here? Activities like on that sheet.
So we need a.
Right there, so it's
Sorry for that.
this is
Good night, everyone. Thank you very much for being here. Here was Thanksgiving yesterday, right?
Yeah.
So we share. Well, my name is Andres. I'm a lead mobile developer at Nventive, and I come from the Montreal, very close to Toronto. My first time presenting in Toronto, and I hope you enjoy what we're gonna be talking today. So the whole topic today is about building rich web apps using WebAssembly and C#. Basically the whole .NET. Anyone have heard about what WebAssembly is? Have an idea? Sure, so it's gonna be fun. We're gonna start from the beginning. As mentioned before, I run the user group, the sibling user group in Montreal. This is exactly the same name, Montreal.net mobile user group, yeah. And so you are invited. If you're ever in Montreal, we make presentations the second Wednesday of each month. We have been running Meetup since 2015, almost 4 years now. And yeah, we're always glad to receive new people. And if you're willing, if you have something that you have already speak here, but you feel that you wanna be in another, talk about it in another user group, you are all invited to go there too. So why WebAssembly? So let's try to grab why WebAssembly is coming to the picture now. So we have desktop and mobile applications, and we have the web in the other side. So whenever we need to build an application, these questions come to us: what should we be building? Mobile, a desktop, if in case it's gonna be consumed for the desktop, or it's gonna just a web that can be deployed easily and all this stuff. So the advantages of doing a desktop is that you have more performance, because you have that native APIs that the desktop provides. And another thing is that you can have doing desktop applications is that you will have different language to choose for the application that you want to build. That in the other side of JavaScript on the web, you will have, if you want to do applications, you will need to deal with JavaScript. I don't know if you like JavaScript, but if you do, I won't say anything. But in my case, I do prefer doing C# or F# now. Any Visual Basic developer? Unfortunately, WebAssembly is not for you guys. I don't know, Microsoft had the same with Xamarin, but let's hope probably in the future will come. So as I was saying, when doing desktop, there's a lot of different languages that you can use. And the most important part of doing desktop when you're doing native is that you have access to more than one thread. Means more performance. JavaScript and the web is only single threading, and there's a few workarounds, web workers and stuff, but it's not as performance and going like full multi-threading. And we can feel the power of multi-threading when we use async away, which is one way of doing multi-threading in .NET. because that allows you to do. That allows you to rely the heavy process to put it in another thread, which is not the UI. We have two ways. So we have a client-only UI. Well, it's also known as SPA, single page application. This is the application that you have all the process in the back end, but you have a UI that is handled by a framework. Usually those frameworks, the most known of those frameworks are React, JS, Angular, and Vue.js. Those are the three kids on the block that are actually the most used right now. And when you go with the approach of mobile desktop like deployment, PWA, which is another term that people is using, the progressive web applications, something that you gain is that you don't have to go through the authorizations of the stores. Who of you have published in Apple? You know the pain that happens. I know we love Apple, right? But the development cycle is nice, but the approval can become really hard. It's getting way better now. You can have even 1 day, but when doing this type of application, you don't have to go through those processes, because actually you're not publishing on the market. You're publishing a website that's gonna be consumed later on the web. We're gonna see that later. Doing this also, as it says, you reduce the use on the server. Time on the server, processing time is more money, and when you have a client side doing part of the business logic, you don't have to go to the server every time you need to calculate something. That's what these libraries came to help with. All right, but what is WebAssembly? WebAssembly, in short words, can be described as a low-level bytecode. Other people call it intermediate language of the web. As we have intermediate language for .NET, WebAssembly is going to be the intermediate language that is going to be on the web, which have two different formats. Binary. This is the format that is going to get you the performance that we are looking for on the web. And as of now, it's already supported for all major browsers on the web, meaning that even Safari is already supporting. We all know that Apple can be sometimes, but it has done it for good, because previous implementations of calling it another way, let's call it Flask, let's call it ActiveX, let's call it the one from Microsoft, Silverlight. They provided security breach, and Apple was the one that said, no, it's not going to be run on my browser because I don't want my users to be unsecure when they are surfing on the web. So, but we're going to be talking more about that. So, talking about WebAssembly, WebAssembly can have key points, and the most important here is performance. That's the most important thing that WebAssembly is aiming for. The problem with JavaScript is that JavaScript first is parse. So every time that you load a JavaScript website, the whole JavaScript engine needs to read and parse the JavaScript, which takes time. And to make it worse, that is happening in a single core of your CPU. It doesn't matter if you have 10, it will run only in a single. In this side, we have what would be the same application, but with a WebAssembly. It's compiled, because it is an intermediate language, means that it already did a pre-compilation, and it's in a format that the browser will understand. So performance. And the way it decoded, it will use every single CPU that you have on the device, on the machine. So what is the reason of having 4 core processors when the technology you're using is only using 1? This is one of the things, one of the key points of WebAssembly. The second one is that is secure. Secure as JavaScript, because it runs in the same security context as JavaScript. It basically is avoiding the same mistakes previous technologies that were trying to do the same had. As mentioned before, Flask. The reason why Flask is not right now is because of security. The same with ActiveX, the same with Apple, with Java applets, and so on. And most of the technologies that we're trying to fix to get performance on the web, they were creating a security breach to the users that were running those technologies. But it's something funny of WebAssembly, and the name implies that it only used for the web, and it is only an assembly, which is neither are. WebAssembly can also be used for cryptocurrency, means that the WebAssembly application can run on top of the Ethereum network. As well, it can also run on these technologies that are there and other more. This is the beauty. Any language can compile to WebAssembly, because WebAssembly is not a coding target, meaning that you don't code WebAssembly. You compile to WebAssembly. So you can use your C# knowledge, you can use your C++ knowledge, you can use your Rust, your Java, your Go, whichever is the language that you prefer, and you can make a compile to WebAssembly. That will allow us to port all the current technologies that we already have, all the libraries that we have, the ACR dialogues that we love for Xamarin. We can share it, import it, and share and use it in WebAssembly. So it's huge. This is so huge that there are already people porting things that I had never imagined I would see on the web, like AutoCAD. Who saw the Google I/O this year where they show AutoCAD running on the browser? That happened. That was for real. They started working on porting AutoCAD, and it was running on the browser. Of course, this is still experimental. There's still some performance issues, but it's a thing that is happening right now. The same happened with Windows 2000. Have you saw Windows 2000 running on the browser? No?
I saw that.
No, so we need to see this, because when I saw that, it really blew my mind. There is. Let me use the best browser. If you doubt it. No joking. This is.
What's the link?
I'm gonna share it. It's a long link.
It's interactive, man.
It's interactive. You can run menu, you can play solitaire, you can play the, yeah. Basically, this is a virtual machine, a virtual machine running on Linux, compiled to WebAssembly, and it's running on the web. This is true. If you had lived long enough, you will remember this.
I do remember Smooth Mouse was a thing back then.
This was my favorite, free cell.
Yeah.
And we don't have it now in newer versions of Windows. But all this is thanks to WebAssembly. So this is the future, and this is why a lot of companies are putting a lot of effort, and the big browsers are supporting this. This can run on Mozilla, Firefox, Microsoft Edge, and Windows Chrome, and Google Chrome. It's amazing, right? I'm gonna share the link so you can play around. It's still a little laggy. You feel that you click and have to wait a few seconds. If you have a good connection, it's gonna be better. But just by seeing that, you will understand how far we can go with WebAssembly. And yeah, we will have Unity is already released. It's already working on creating games that will run on WebAssembly. So imagine that you will no longer have to be downloaded all those huge video games that you can play just on the browser. That's going to be huge. And as you know, Unity also runs on top of the .NET and Mono. So you will have the whole C# and .NET ecosystem. So what is the architecture? So as mentioned, you have any language of your preferences. If you like C++, if you go really low level, or if you like C# and Link and all the beauty that .NET provides, you can compile that language, that code into WASM just by selecting a target, compilation target. The same way you compile to x86 or x64, 64 bits, or ARM, which is for mobiles. And this WASM can talk directly to the CPU. This is where the performance comes, because you don't need JavaScript for this. But you can also use JavaScript to communicate to the CPU, because this communication with JavaScript is the one that will allow you to use the existing APIs on the web. Let's say when you do a web application, you already have access to the user location. You already have access to the push notifications on the web. You already have push notifications. All those APIs are thanks to this. W3C APIs that you talk through JavaScript from the code, because from here you won't be able to do it. Here you do the heavy processes, but whenever you need to access the web APIs, you talk to JavaScript. So this is not looking to replace JavaScript at all. It's not, oh, it's gonna kill JavaScript. This is the new JavaScript killer. No, it's actually working along with JavaScript to do a better job. It's like to do what JavaScript is not able to do in terms of performance. So let's see a little bit of WebAssembly. Let's There is a WebAssembly Studio, a web application that you can use online, and you can test your web assemblies. Let's create a MTC project. Create. Let's use C. Who remembers C from school? So this tool created by Mozilla, if I'm not wrong, if I'm not mistaken, it allows you to create some web assemblies, to create some code in C++ and compile it into WebAssembly, so you can see the output, how it looks. So if we run this out of the box, this is like the hello world of the WebAssemblies.
Can you make larger?
Yeah, sure.
Command up. Oh wait, you're not using Mac.
Let me see.
Nice.
Much better? All right. So build and run. We receive, of course, the 42. We come here, and this is the representation of the code that we saw before. So this code, which is just a main entry returning 42 as a constant, is, and just some definition on the header, is translated into this. This is what WebAssembly looks like. But you don't have to code this. It's like you don't have to code assembly code. We already have compiler that do all the code. The same will happen here. As you can see, you define a function. You say that you're gonna have a result which is an integer. You call the constructor. The main is called main, and you have a parameters. You have result that's integer, and it's returning a constant. The compiler knows it is a constant, so it doesn't have to parse the value to know that it's a constant. So what will happen if we do some modifications? Let's say that we have 42. Let's just save it. Hit and run. We got the same 42. And if we come here again, we see this. The code didn't change at all. Why? Because the compiler understood that there were two constants that they were summing up together, and it just did the work before processing. So when this gets to the browser, it's going to be already compiled in a way that the browser would not have to make the sum 21 plus 21. And if you don't believe that it was actually a change, we can do some modification.
Save the file.
What's this?
Command S.
So 40. Now we have the 44, and we can see that it's actually a constant that is happening. So this is where the performance is coming from. Heavy operations that the compiler will do some pre-compilation of those operations and returning only what it is required for the browser to display. So the browser will not have to be doing those operations on top. Let's modify a little bit more. Let's come here and create here what we're trying to do is just a function that will add two numbers and we're going to replace this
Is this the virtual CPU? Like right now, we are working on a virtual CPU for WebAssembly.
Is this a virtual CPU? Virtual environment?
This is a virtual environment. Yeah, this is an online WebAssembly Data Studio.
The CPU, like, are we reaching the real CPU or are we reaching like the virtual CPU? Like return, you say return 42, for example. This return is going to the real CPU hardware or the virtual CPU?
This is a virtual CPU. I don't know if you understand what you're asking. That.
For example, when we are coding C,
okay.
So we are reaching like all kind of, for example, this is software interrupt. So we are doing the interrupt for the real CPU processor. But I'm asking, is it a real CPU or right now we are making the process or the virtual CPU?
This is a real CPU. This is compiling into C and it's returning the compiled version of the C into a WebAssembly and the real CPU. Because this is running in real.
Call to action.
Oh, yeah. Yeah. Thank you. You can have the private thing. It doesn't require the private thing. Yeah, so yeah. Here we have a new version, but this time we're using a function. So, but if we come again to the WASM, we see that we're still having a constant. Why? Because even though we are using a function, the two numbers that we are passing into the function are constant. They won't change. So the pre-compilation already find out that it can do some performance on the whole code, and as a result, it's just returning the constant. Every time we want to export a function available to the JavaScript, so JavaScript can see it, we use this pre-compilation. We use WASM export. And from now on, this library is going to be available to the JavaScript. We can see here. It's going to be available to any other program in the JavaScript that can call this function if we ever need it. So, questions about this? this is a very fun way to understand and learn more about WebAssembly and the compilations. If we run this in JavaScript, we will see that it's going to be parsing the function every time we run the program. As we saw here, there's no parsing. There's a pre-compilation, and the result is just displayed there because it won't change.
So if I wanted to test on my own computer locally, what would I need?
Just WebAssembly.studio.com.
Okay.
You don't need to sign, and it already it's a studio that has all the it needs to compile. Right now, it supports only C and Rust. With C, it's good enough. You might have to remember a few things from C.
If I wanted to make a personal project, I would have to do it on WebAssembly.studio.com.
No, we're gonna go there.
Okay, cool.
We're gonna go there, and this is the whole things about WebAssembly is that a lot of technologies are already working on towards creating tools for making it easier for you to experiment with WebAssembly. So WebAssembly and .NET. This is where our work started. Our work in terms of .NET developers. The whole WebAssembly started in 2015 in June. That was when they first announced. But it was later, a year later, that the first tech review came around. And 1 year later after that, 2 years later after the first poker, they first announced that they created the first MVP. But until then, there was no browser support. I mean, no browser support for all the major browsers we saw before. The browser supports came later in 2017, and I believe that this is where the whole industry said, oh yeah, we should work on top of this. Because it's one of the very few times when all the browsers agree in something. If you have been web developer before, you know that there are many issues even with JavaScript. There were browsers that run on version of JavaScript, but another browsers do not run another version of JavaScript. So that's why you have libraries like Babel that allows you to have different versions of things in different browsers. And the Mono experimental came in January 18, so that means this was a couple of months ago. This is how it's implemented. We already know that when you run C# and F#, I'm sorry, BB Games, it's not me. When you have C# and F#, you compile it into an intermediate language, which is a .NET IL. We already know that. And that IL which is compiled on top of Mono runtime, will be compiled into WebAssembly. And then what we saw before, from that WebAssembly, we can go directly to the CPU to do interactions with CPU, or we can go through JavaScript using EM scripting to let whenever you need JavaScript to do something for you. Especially, we use this to print in the UI. There are many ways of printing, but let's say that until now. One way to answer your question. Your name?
Samer.
Samer.
Like Samer.
Samer. Nice to meet you, Samer. To answer your question, one way for you to do WebAssembly coding right now is by using this library. It's just a NuGet package that you drop in a .NET standard project, and you are able to run that code into WebAssembly. You don't trust me? I'm gonna show you. So I see your face is like, no, that's not true. But yeah, it's true. That basically, this is a bootstrap and takes the .NET standard and create the WebAssembly link that you need to run to talk to the browser. Let's call Visual Studio, and let's create a new project.
I think James Montgomery, the famous Xamarin developer. He talked about WebAssembly in one of his podcasts as well.
Who was that?
James.
Yeah, because there's another approach to doing WebAssembly with .NET that is called UI. That is it was created by Frank Krueger, which is the co-host of the Merge Conflict with James Montemagno. So yeah, this came when Frank Krueger showed that what he could do with SAML and ported to WebAssembly. The guys at Nventive and the Uno platform, they said, okay, let's try what we can do, because later I'm gonna show you what is this whole Uno platform. So yeah, let me show you the way you can do it with this library. So basically, you just create a new project, .NET Standard, class library, .NET Standard. WebAssembly Toronto. Change the Finder. Right. Okay. So you have a class. Why is complaining about system? System should be everywhere.
Still restoring .NET Studio. Give it a minute.
Let me check on the namespace class. May, because we need an entry point of any program. String argument. So we have our program. We're gonna add the dependency we need. Manage NuGet package, and the name of the library is called Uno wasn't okay. Here. Oh. Okay, here it is. Uno wasn't bootstrap. It's just a bootstrap. Doesn't do more than a bootstrap. It is in a pre-release. So for you to find that, you need to click on this to include pre-releases. You install it. Say yes. And let's do something here, because the class is not doing anything. System console. Every first program that you write has to be a hello world. If you break that, so right, we already had the solution. We just reveal or build. Yeah, this is something that the library that we are aware. It's just by the new way the NuGet package works, we cannot modify it, and we need to rely on printing the instruction for you to do it. So basically what it's saying is that you need to change the package, the project. No, edit this. Yeah. I don't know if you can read this. Oh, no, it's too small. Basically, it's saying that the library is missing an entry point. It's just a .NET Standard. .NET Standard doesn't have an entry point. When you execute it, there's not going to be a way for the program to know where to go first. So we need to manually add it, and that is by item group. time, and it said that put executable. That's it. We just reveal. That's it. We already have our WebAssembly application. To be able to run it, we need to get the route that is here. And if you can see, it's really small, but I don't know how to put bigger. But basically, that's just the path where the library was compiled to. And by making use of the Linux subsystem, we're gonna run a mini web server. This is amazing. Ubuntu running inside Windows. This is amazing. So, path cd path shift I forgot something here. Basically, what I'm doing here is that, you know, Windows path is this, and Ubuntu path are this. So there's a tool, oh, the other way. Windows path is this, and Ubuntu path is this. So what we're doing here is that we are converting that path to the other. And there is an internal tool that is called WSL path. You put the Windows path, and it gives you the Ubuntu path inside Windows, so you can navigate. Basically, what I did was navigating to the project, to the path inside Ubuntu. There is a directory that is created once you compile called dist. Can I put this bigger? Let me see. Much better there? Yeah. Even for me, it was kind of small. So this is the route that gave me the Visual Studio here. I just used the program to create the function, the utility to create the Windows-based path to Ubuntu-based path, and did a CD at the same time. There's a distribution, this directory. I entered the directory, and once there, you just need to run Python and call this file called server PI. Let me see. All right. This is because I had something running before. Wait a second. This is because I had this. Here, just cut this one. Being able to run this one. Yeah, the utility is pointing automatically to the port 8000. So make sure that you're not using that port, or you will be having issues. So right now the application is running. How can we test that the application is running? So we come to the website.
Wait, what did you do with Python again?
Just Python, and there's a file called server PI that is created by you for the wrapper. So you just run this file with a Python. It's a Python server. So basically, we are just running a Python server to host our application. Yeah, amazing, right? So we are running Python to run a WebAssembly application that's gonna be running on the browser, but it was created with .NET and Mono. So to test it, it's just running localhost and the port that you have that was pre-selected for you, and you will have the application running in a few minutes.
So what is taking so long?
It's not Wi-Fi, because it's in the localhost. It might be, I don't know, there's some rules in the Wi-Fi.
Shouldn't be.
Because I'm just connected to my computer. I can disconnect to the from the Wi-Fi and retry. The server has not received any requests yet. So everything is happening on top of the server.
Maybe it's Visual Studio.
It could be the browser. No, because it's not running in Visual Studio anymore.
Oh.
No, the Visual Studio just compile the file,
Oh,
and you just
okay.
take Python to run the server. So it's already away from Visual Studio, and the server is not receiving the response. Let me try using the best browser. Why you laugh every time I say that?
It's the fastest browser
Yeah.
in the world.
You have the road for localhost hijack?
Do you have particular reason?
malware taking it over.
There should be something.
Yeah, try 127.0.0.1.
Do you have particular reason to write Python as a server? Why? Because C# server is better. Why do you run Python as a server?
I'm sorry, the IIS you
Why
mean?
do you run Python as a server? Because
Well, we're using a tool for Python because the main goal of this is using Mono, and Mono, the ability to run in every browser, on every platform. If we go with IIS, which is will be the web server, you need to configure a whole IIS. This is just a demonstration. You can use any browser you need, any web server you need. We're using Python for simplicity. It was quite simpler just running Python a command line than configure IIS and permissions and
So you could probably host it like, you know, in Linux, but you can't do it over like FTP.
yeah, because it's just a file. I mean, the final file, we're gonna see later a few solutions that are just hosted in a file server. You don't need a web server to run it, definitely. Just because you're pointing to the application will be able to help itself respond to the request. Because when you call the WebAssembly, that WebAssembly call is gonna be your app. It's not like communicating like one page, 2 page. No, the whole application is on top of you. Let me disconnect from the network and see if I have better. This is weird. Yeah. I don't need internet now to test this. Localhost. Oh. There was something happening. Okay, so now loaded. There was something happening with the web server. I don't know if it was Wi-Fi related and now disconnected. But we can see it's not showing anything. Why? Because we are not presenting anything. But the way for us to see if we are actually doing something is by watching this. How can I make this bigger? How can I make the whole browser?
Try Control Plus.
It says hello world everywhere.
Yeah, thank you. That worked. That hello world is what we printed out here in the console, in the application. It's just as simple as printing here. You can have access to the console of the web browser. You change here, you recompile, and you rerun, and you will be able to see the changes. But what if you want to access the UI, the canvas itself? You can by using JavaScript, as mentioned before. I'm gonna add this functionality that it's basically a JavaScript code to append data information to the DOM. For that, we will need to create a new folder that is required by the library. New folder, and inside the folder, we're gonna add our code, JavaScript code. Any JavaScript that you want, you can add it here. JavaScript. Oh gosh.
Filter the web though.
Do a text file and call it.
Yeah.
All right, we're just gonna test this. Yes. Alright, so I don't need this. I'm gonna add my JavaScript code. Basically, what we're doing here is creating a new element of type P, paragraph, and appending a new test, which is we're creating a new text node, and we are appending the node into the body. So it's the way JavaScript used to be 10 years ago, probably more, probably less. But by going to the DOM itself. This is just a sample. There are better way to do it. So for us to access the JavaScript node, we would need a library that comes with a bootstrap that can be found in existing item. Where is it?
So how did you fix that issue of the server again?
The server, I just stopped the server and
okay.
didn't do anything.
Okay.
Wait a second, I'm looking for I forgot to copy there's a directory. Copy tab. On a wasm, okay. Bindings. There is a problem. Yeah, we are documented this. This library that I got is the way the bindings is this one here is one way that is the bootstrapper that we did for the library for you to communicate with JavaScript. Why don't we just include it directly into the source code once we include the library, the NuGet package? Because of the way the NuGet packages are working right now, and this is changing. We didn't want to just add it as part of the library, and then you will need to access the WebAssembly. So it was a problem with the way NuGet package where we're working on this to make this easier, because the way it's happening right now, you have to go to a directory. It tells you in the law, you need to go to a directory where a package is downloaded, because we don't download the compiler. We don't include the compiler into the solution, meaning that the compiler is downloaded and put it here. Did I close this? No, it's closed. It's in the temporary app data, and then the file is living there. So for you to add it to your project, you will need to go there and add it. That's part of the documentation that we're adding until we get this fixed. So basically, this library that I just added here, this file, a C# file, is the way for us to communicate with JavaScript. And how we can communicate with JavaScript is by using the namespace invoke.js runtime. Runtime that.
Is that bindings a file on the GitHub repository?
No, that file is, well, it is on GitHub repository, but it's part of the library that you download.
Okay.
The only thing is that it's not included automatically to the project when you include the library.
Okay, so you just included it?
I just went to the file directory where the log tells you what it is,
Okay.
and just add new file, existing file. So you invoke JavaScript, and here you just call it JavaScript. The JavaScript that you're gonna be invoking is the test, because this is the class that you have here. It's called test, and the function is called add element. If we recompile and we just stop the browser, compile successful, you stop, run the browser again, we come to the page, we refresh. Test is not defined, a WebAssembly runtime error, there's an error. It's not that error is happening because we see that the changes we just made are part of the error. So the changes are applied. Test is not part, okay. The problem is that whenever you add a new JavaScript, you need to change the action to be embedded resources, so that the JavaScript is copied along with your code whenever your code is compiled. We just rebuild, we just rerun, and we have here an element made available to the. So it was a very simple sample of the WebAssembly to the JavaScript and made JavaScript do things that we need from our applications. And the communication is both ways. JavaScript can talk to us later and let us know. Right, so we saw what Uno Watson is. Oh, sorry. Basically, this is what we saw, the sample, and the way we updated the DOM, which is the JavaScript word, or the HTML word, the JavaScript, where you use JavaScript to modify it. But there are many ways for us to change the HTML that is displayed to the user. So to change what the user sees at the end. We have HTML native. HTML native is that you write HTML and you will have HTML. This is the approach used by Blazor. If you have heard about .NET and WebAssembly, this is another approach that is happening right now. Meaning that you do web applications, web app using ASP.NET and Razor templates, but this is called Blazor for the WebAssembly version. Basically, you will have this and you will get this at the end. This is another, as mentioned before, this is another way of doing WebAssembly with .NET. But this will require you to do web instead of SAML. Another approach is using Canvas. Qt wasn't also known, and in this case, what is happening is that you just get a canvas object on the browser and you start painting pixel by pixel what you need to display. This approach, it's good for really heavy or UI that you require a lot of work, but you will have a disadvantage that every canvas that you display, you won't have the native field. Let's say that you draw this text box, but this is not a text box. It's a canvas, a byte draw as a text box. So you won't have the long press of the text box. You won't have all the APIs native of the text box. Sounds familiar, this?
Flutter.
This is Flutter. Exactly. This is the way Flutter is doing now, the mobile, where it paints all the UI. Has an advantage, has disadvantage. Just use it wisely. And the last one, which is the one that we are using here, is the HTML rendering, which you can do it by using Uno platform or by using the UI, which is the version we just mentioned before that was created by Frank Ruger. And this one is using Xamarin Forms, and this one is using Xamarin, UWP SAML. Yeah, that's something else. This is using UWP SAML. So this is the UWP SAML, a stack banner, text blocks, and this is translated into this. You have the text blocks, the text stack banner is a P, and text blocks is you create a div, you have the text inside, you have the styling and the stuff. But yeah, this is the way it's happening. And now that we have gone so far, it's good to talk about a little bit what Uno platform is. It's just gonna be a small introduction because I'm gonna keep focusing on what Uno platform does for the WebAssembly. And so basically, Uno platform is another way of doing cross-platform applications using .NET. People say, oh, Xamarin is there. Yeah, but Xamarin will force you, if you go with Xamarin Forms, because we love Xamarin. We are on top of Xamarin for creating iOS and Android. What we do is another approach of using the UI. While we are using the UWP SAML that you already know. See, if you're a UWP developer, you will have to learn a new set of tools or a new set of APIs for you to do cross-platform application. That happened to me, happened to many others that are Xamarin Form developers, but we cannot use fully the UWP that we know, the SAML knowledge that we know. We cannot. Because text blocks is not a text box in Xamarin Forms, it's a entry, and then you have a label, which is another thing, and then, so those comparisons, you need to be switching if you are working with Xamarin. Our approach is that we go UWP first, because of all the richness that UWP provides. If you go in UWP, just by clicking on run, and you have the application running right away on your computer, and you modify, you don't have to be stopping and recompiling again to see the results. The whole development cycle is richer in UWP. Yeah. And yeah, we have the UWP, because we go UWP first. We have the WebAssembly, that's what we just showed a few minutes ago. We have Apple and Android. So it means that your applications that you run, the application that you run, that you create using UWP, .NET can run in WebAssembly on the browser, can run on Apple devices, and can run on Android devices. This is not new. This has been around for a couple of years, but unfortunately this was a proprietary before, and like a couple of months in build, it was released as open source. So that's why it's now getting traction on the community. But before, we have been using this product for 5 years to create application for customers, happy customers. And this is the mapping. Basically, you have, as mentioned before, it's the same process as you have seen in Xamarin. You have an iOS label. You create a SAML text blocks, and you will have the representation of the iOS UI label. You will have an Android text view, and for WebAssembly, you will have the WASM HTML paragraph. So it's native. It's not an hybrid application running inside, and it's really native application. That's why we rely on Xamarin to do the work. But it's not only UI, we also do the mapping on the APIs of the devices. Meaning that whenever we're using the user defaults of iOS, we're pointing to the Android preferences and on the WASM IndexedDB, which there is a sample. There was a project that was released a couple of days ago where one of the developers of the Uno platform made available SQLite.NET running on WebAssembly by making use of this, making use of the database of the website. Yeah. So what can Uno platform do other than the Bootstrap? Well, as mentioned before, just the Bootstrap is the entryway for you to try and do WebAssembly applications. But if you are already a UWP developer, you can now start doing some WebAssembly apps by using Uno platform. There is a sample code. We love samples. We love coding. For the time. Oh, I was gonna. For the time, instead of just going through the whole application, I will just create a template, show the template, and then show the application that I had running before coming, which is the same that was presented before. This is to give some time for the questions at the end. So first, how can we get you Uno platform in your Visual Studio? As simple as coming to tools and add extension and updates. You search for Uno platform and solution templates, and this is just templates because the Uno platform is a NuGet package that gets installed on your application. By installing this, you will have the ability to do a file, new project, and by coming in C#, you will have these two templates. Cross-platform library, Uno platform, and cross-platform application. The application is just the same. The library is a .NET standard, already bootstrapped with the Uno platform. And the application it will create the distribution of UWP, Android, iOS, Azure, and WASM, WebAssembly. That basically, this is what we have here. If you can see, I have already a Droid project, iOS, Azure, UWP, and WASM. So let's say, and all the share code is going to be in the share. We have the application file as a UWP app. We have the main page as a UWP app. And let me change this.
That's crazy.
Yeah. So yeah, the whole goal is go UWP first. Basically here, what we did is that we have a grid, have a test block, and we have a slider. Let's remove this so we can see. Let's run it first on UWP by just changing.
Did you guys speak at Ignite or something like that about this?
Yeah, I was there.
I would imagine.
I was there. So this is a UWP app. Already UWP app, you have, as we show here, you have the binding, the slider, which is the test blocks. The value is bind to the test. Simple binding. One of the beauty of SAML, the bindings. And yeah, simple application, and the same application can be run. I don't know if this is gonna work now. Yeah, that's the thing with Android. So the advantages that I was mentioning before of the UWP is that the whole developer cycle is rich. I don't need to stop the application to do any modifications and see the result. Meaning that if I want to change the font size here from 45 and I want to put it in 85 and 80, I just save and I just come here and the change happens instantly. So this is UWP. This is how it works. You can change the color, you can change the UI, and you receive the feedback right away. You don't need to be stopping, recompiling, and sometimes deleting the objective folders in the beams. We all know that sometimes happens. And that's it. I mean, we have the whole application cycle. Okay, once we have this, once you have the application you want to publish to iOS and Android, it's just a matter of running iOS and Android. There will be cases for sure that you will need to restylish because of the style that you apply is not correct. For Android might be the font is different, or I don't know, whatever. There might be some touches, but it's minimal. It's the same Xamarin ecosystem. You build for one, you focus on one, the one you like more. I usually focus on iOS. I do an iOS application, and then I just check that iOS is working fine, and I started like comparing that I have what I have here. In this case, you will have a UWP application. You will start running. Once you feel confident with it, you will start running the Android and the iOS, and you will have the whole three. But now, just out of the box, you will have the WebAssembly application. And we can see that.
Quick question.
Yeah, sure.
Can you build UWP on Macs? Or do you,
No. Unfortunately, it's Windows.
Okay. But can
Right
you
now.
build this stuff on a Mac?
Because it's the same. We're using the whole UWP tooling, so you would need a Windows computer until now, until UWP can run and compile, at least compile in Mac.
So you can't build WASM until you can, like even the WASM project you can't do.
The other one,
WebAssembly.
this one no, because
Okay.
this relies on UWP.
Okay.
But the first one
First one,
yeah.
Okay.
So I wanted to run it on Android, but for some reason it's not being recognized. Who has a UWC?
USB-C.
USB-C.
Oh,
Yeah. So see if it is the cable. It was working before I come.
Demo magic.
When you were running the app, so when you
Is that what you're looking for?
Ah, it's still no, it's USB-C.
Oh, USB.
USB-C. Yeah, to connect this. It's alright. It's alright with. I have the sample running here because I was running before. Let me show you if I can.
USB-C.
yeah.
Thanks. See if it is the cable. Might be the cable.
You can do it on on an emulator too, isn't it?
Yeah, but I don't have any configure. It's
Oh.
alright. Alright, let's continue. Let's show okay, we have the UWP app. I was gonna show that you can run the same application on Android. I was running before coming here. You will have the same user experience. Because the way the framework works is that it will create the same user experience unless you tell the framework by styling to use a different user experience. We can have another talk about all about Uno if you ever decide to listen more about Uno. This is more about WebAssembly, what Uno can provide. And so the same application now, you just need to compile it and run it, and you will be able to see the same application in the browser. Let me just stop this and use this that I was already, let's say. See when it change. Okay, even the splash is the same.
And which drivers, like CAN or other sound drivers?
Yeah, the sound driver is one of in terms of Uno platform, the sound driver is the one that is working on process. The whole reason of coming open source is that UWP APIs are huge. There are many, and a few teams of developer was really hard to catch up with all the things. So we are working on the audio on the.
All hardware, like CAN, all of them.
No, we have many already working on. We have already the some of the hardware specific device, hardware specific APIs. We already have access from the Uno. But the audio one, the specific, is the one that we're working on right now. So yeah, this is the application that was created with Uno platform and compiled to WebAssembly and running on the browser. It is exactly the same application as if you are running I wish I could have side by side. I changed the, so you have this and you have this. The same application running in 2 different operating systems and 3 operating systems. And iOS, we just need an iOS build computer with Xamarin and build to iOS. So here we didn't have to configure anything because out of the box already configured. When you just create a template, the WASM template, the WASM project is included, even though you won't use it by now. Questions so far? All clear? Or do not understand anything? So yeah, this is basically what we saw. We can rely on the SAML that we like and love and have the same user experience for all the different platforms, including WebAssembly. And for me, this is great. Just by being able to do my bindings and being able to use it here. So that's one of the reasons that I love the cross-platform development using .NET, is that either is by Uno platform, you have SAML, or by Xamarin Forms, you have SAML. And this is great, the bindings. You don't have to be going like text for that, text to put the value, unless you go with it. There are all the libraries, but with iOS, it's really hard to do bindings by the way they work with the storyboards, unless you go with code instead of storyboards. But yeah, also, the good thing about this is that we can have all the libraries that we already use. So let's say that you have a React.NET, React UI, I love this one, MVVM Lite, Prism, so name it. We already migrated this, and by migrating it's just a wrapper, so it can run in the Uno platform, and they are performance as they are, because the wrapper doesn't do anything more than being able to use it by Uno. So all of these are already part of Uno. You can use it and uses this to WebAssembly. That'd be us, having reactive native, reactive UI in WebAssembly. So there's also a way for you to try and see what the Uno platform has is by going to the playground.platform.uno. There are some cards over there in the table and some stickers if you like stickers. And it's the URL for the Uno platform. And you can start playing with what the widgets we have, the transition. You can see the performance. But the beauty of all this is that this whole website, web application, was built using Uno, and it is a WebAssembly application. So we're showcasing what we do by showing what we have done in the application. And let me see if I can enter here. We need to connect again to the view. Connect.
So you also have an app called Uno Gallery?
Yeah, there's an application in the markets, iOS and Android, where you can see the different controls and play around with that. Let me see. Platform. It's Platform Uno. Here you have the playground, try live, open source. You can go and see the source code of this. Yeah, there you have it. And you can play around with changing the properties on the left side and you will see the result happening on the right side. This is the whole a point to note is that the whole WebAssembly is still experimental. There's still work to do, especially on the performance. And you might feel sometimes that whatever trial that you're doing for WebAssembly, no matter it's .NET, Python, Java, you'll find sometimes a little bit laggy. But it's because of the process that people are still working on it. So the performance will change, and will change especially when because right now the WebAssembly is being parsed as JavaScript. But the whole goal is to have it compile in AOT, the way Android works ahead of time. So you will have the pre-compilation already. You don't have to be parsing the WebAssembly.
When we will see that, like when we will see it.
When we don't have the date, but all the communities, Python, Java, Go are working on top of making that possible. Yeah. And there is where you're gonna see the real performance of WebAssembly. So here you can see the animations, you can see the borders, you can see the cards that you can create with WebAssembly, with Uno platform, and can run right away on WebAssembly. Let's say, yeah. If you get the application from the market, the gallery, you will see in your phone that runs quite faster. But as mentioned before, WebAssembly is still experimental. We're hoping that the performance can be increased in the next days. Where is this? Yeah, these are the execution modes. Right now we are here. We are interpret. The goal, ahead of time compile. This will never happen for security reasons. I mean, the whole WebAssembly is about security and performance, trying to do both at once. We had speed, we have performance, but without security. We have security without performance. So WebAssembly is trying to fill both cases. And with this, it's gonna be, it's when we're gonna be hitting that performance that we're looking for, the whole WebAssembly world. And so the future is WebAssembly is implementing garbage collection. Right now, the way it's work, we don't have a garbage collection, and so we don't have a host binding support, meaning that we are not able to pass function pointers because we don't have a good way of cleaning. When I say we not as a Uno platform, but as a whole WebAssembly. There's no garbage collection. Once this is implemented, the host binding support will be able to work. And the threading. All three are one aligned to the other, because you don't want to be dealing with threading when you don't have a good garbage collection either. So that's the future. That's what we're expecting of WebAssembly in the next days. In the meantime, just keep playing around with WebAssembly. So by the time WebAssembly says, all right, this is the final implementation, you will have some good knowledge of what WebAssembly can do and can provide to your clients if you are consulting, to your company, even for your pet projects, for anything. WebAssembly, I believe, is the future. 2 questions?
Why shared projects?
I asked the same question. This is the template. Internally, they prefer shared projects. I do prefer PCL or .NET standards now. But internally, that's the template that was chosen. We may create another template that you can choose whether shared projects or PCL. You can use .NET standards. People like shared projects. Cut that from the video, please. Any questions? Just one more.
Right?
Yeah, yeah.
Sorry, I asked so many questions. So they are working ahead of time compiler right now. So they have the best engineers. Why it takes so long time? Like why they can't just that?
Specification.
Yeah, it's more, you know that when you're working on top of different browsers, you need to as Alan just mentioned, specifications, you can just go and do what you need. You need to be able to, each one of those providers is gonna be running on something that is not handled by the one that is doing WebAssembly. So the browsers need to support everything that, so they need to, okay, they had the agreement with WebAssembly, but it's still work it's still work pending. I don't know if you're a Xamarin developer? Are you a Xamarin developer? Yeah, just to mention something. I mean, when Xamarin came for the first time, it was really laggy. I like the idea. A lot of people like the idea. We jumped into the idea because we liked what we were gonna see. Right now, I like the product that we have seen 5 years after. WebAssembly has been actually being worked for 2-3 years probably. .NET, if you go to .NET part, it's been since January this year. So a lot of things to happen. This is a whole new world, a whole new thing.
So 5 years. I just wondered.
HTML5, just say HTML5. So we're
why-
still waiting for it.
Yeah.
So why did you guys release this for everyone? Like, what was in it for you guys? I know Nventive does like consulting. So
Yeah.
what did you guys have in it?
Well, the whole thing about releasing open sourcing the Uno platform first is getting help from the community, because there are many APIs that still we need to map to the native. And secondly, people ask, even that was the main question at Ignite. So what's gonna be your business model now? So it's more either support for enterprises. Because if enterprise needs support for these products, like you see the Red Hat support. Red Hat is free if you want to use it, but the support that you get from companies like that, that's the business model that we are targeting right now. And everybody loves open source. I love open source. We love open source.
Yeah.
It's quite easy that you need something and you just go and grab it. It's not only that you go and grab it in NuGet, but you also are able to see what that does. That you're not just getting a Trojan horse that you put into your application, and it might be getting the information from the users.
Yeah.
Basically that.
In the beginning, you said that when you load your website, you first get the JavaScript and then parsing it and slapping single thread. But when you do the WebAssembly, it goes in multi-thread.
Yeah, the specification of WebAssembly is that it's going to be multi-threading, and what it would allow is that in the loading time, when you load in the application, or when you do when you load the application, because you will have the whole application. When you go to Uno.platform, that's the whole app running already. You don't navigate to another place than the app. So that when the whole WebAssembly is completed, it's going to run in multi-threading. Also, the instruction that you send from the app to the CPU to do any task is going to be multi-threading, allowing you to rely on the non-UI threads to do heavy work. While JavaScript, you don't have multi-threading. You have a way to virtualize multi-threading, but it's not multi-threading per se. Don't be shy. Say two, but I can get another one. One last.
When do you guys think you guys will have a product good for production?
For WebAssembly,
Yeah, like Uno platform.
it is already good for production. There's a few applications already running using Uno platform. Most of them we cannot rely the name because of clients, but there are more than 350 applications using Uno platform.
Like for website.
Oh no, because for the website, since we are relying the whole website, WebAssembly is experimental. I'm just mentioning there's still a lot of work going on, but by the WebAssembly, it's not. We are showing what Uno platform can do so far, but it's not in our hands. It's in the whole our WebAssembly infrastructure that needs to be completed.
You can say, but I guess I can say that the new Cineplex app on the store, it's all built on with the Uno. Like if
So the new
Cineplex app that was just
what about the
released,
website that they use?
No, not their website.
Okay.
So web
Because
yeah,
I mean,
the
we're
mobile
trying
apps.
to get sold to WebAssembly, which is like a website development tool, you know?
Mhm.
Well, it was like Andre said, like learn the technology now,
Yeah.
and once it's hit full maturity, like right now it's got some slim use cases. Get used to how it works.
Yeah.
Once it's fully mature, then you can build a whole site or big apps.
Right.
using
Yeah, and the whole idea is that you won't replace probably your mobile applications, but you will allow the users to have the same experience, even though he's on the web, he's on the native Android, native iOS. I don't know. You will choose. It will be the business to call, but at the end is that it's just providing good experience to the user, no matter if he's using native applications on the device or you're using a browser on the same device. Because if you run this on the browser, you will feel like you have an application, even though it's on the browser.
Yeah.
You can ask one more.
I just imagine like if you have right now is the ahead of compiler, ahead of
Ahead of type compilation?
yeah, it will be awesome. Like,
Yeah. We are waiting for
I
that.
wish like
We are waiting for that.
Mono thinks they're close.
So
They think
this,
they're close.
huh?
They think they're close.
Yeah, they're getting closer. And these are the references of the things that we talked today. WebAssembly, all the information that you want to know about WebAssembly is there. And the future, the path, how is it going, the development. This is the Nventive Uno, this is the Uno platform. This is the bootstrap that we just use for the .NET standard. Here the playground for Uno. Here there are a few cars if you want to take it, have the information for the Uno platform. This is the implementation of the Xamarin Forms for WebAssembly, which mentioned before, Frank Kruger. And here WebAssembly Studio, the website that we use to create some samples of WebAssembly. And yeah, more Blazor.net, the .NET, ASP.NET implementation of WebAssembly. Thank you very much.
Awesome. That's fantastic.
There's a lot of there's a lot of stuff going on. There's a lot of people that have a lot of questions, have a lot of doubts. But to me, I like the idea because, especially I like SAM. I love using SAM, especially for the bindings and being able to use that in web. I used to be a web developer, and in 2010 I said, oh no, this JavaScript craziness. Oh no, I can't. So I moved to Android, then iOS. And then Xamarin came over, so I started doing Xamarin, and then it's been mobile since then.
Nice.
Thank you very much. Thank you. You are all invited to, if you ever in Montreal, just pass by, check the meetups. We have talks every second Wednesday of the month, and we'll be glad to see new faces over there, especially if they come from Toronto.
Thanks for coming, everybody.
Is it in French or English?
It's both. Well, depending. At the beginning we say how many French speakers, how many English. If there are a lot of people that do not get French, we do it in English most of the time. Yeah.
so subtitles.
We're gonna hire people to do the translation.